Okay, so here's your review. Like that, minimize this. Obviously. So problem number 1, and I thought I had the answers on here. Stand by one. Okay, so number 1 is 1 point. The answer is choice 1. Number 2 is 1 point. And the answer is choice 3. Does anybody have any questions on either of these two? All right, like number 1, maybe you don't remember, like these open circles that you see here means it does not include that point. So you could draw a vertical line and only hit it 1 time. Paul, you were going to say something?
Yeah, I was going to ask about the open and close tab, but I guess
right. You learn that in algebra, right? Like over here, if I try to do the vertical line test in number 2, closed and closed, right? So I do hit it twice. Over here, there's nothing there, so I only hit it once. Does that make sense?
Mm-hmm.
Okay. And how about number 2? 1-to-1, right? What's the test? What's the test for a 1-to-1 function?
Horizontal line.
Right. Okay. So that's page 1. So like I said, if you don't have a copy of this, you might want to write down the problem number and at least jot down the answer so as you work through when you get it, you can check yourself. Okay.
Aren't you going to post the video on Teams also?
Yeah, I'm recording it right now. Because we're
Okay.
going, what we're doing right now, I will post. Okay.
Got it.
So number 3 is 1 point in choice 2. 4 is 1 point choice 3. 5 is 2 points choice 1. Now number 6, it's very specific, right? Set builder notation, right? All y such that y is greater than or equal to 2. Okay, you got to have the, not just greater than, right? But greater than or equal to, and it's 3 points. And then number 7 is 3 points. The inverse looks like that, 2x plus 8. What questions do we have on this page? Because remember, when you are actually taking the test, I do not answer any questions. If you tell me, hey, Mr. Hefter, can you remind me how to do this one? I would just say, no, we did that on the review. Well, somebody said something?
So can you go back down to 7?
7? Yeah. Questions on this?
Was 9 not on the line in 0, 3, 2 minutes?
So this says, okay, which value is in the domain, right? So you got to know what domain. What is domain?
X.
Domain is all these values, right? And the range is all these y values, right?
Mm.
And then we get that out of the way. And in this case, right, it starts, the domain goes from here to here, right?
Mm-hmm.
Right? So the domain has all these values. And the range, what's the highest value? Like up here, goes from here down to here. Does that make sense?
Mm-hmm.
So you're finding a number that's in the domain, but not in that range. Does that make sense?
Mm-hmm.
And if you go out here to 9, 1, 2, 3, 5, 6, 7, 8, 9. Well, that's just barely. It's right. It's in the domain, but is 9. It's way outside the range, right? Does that make sense?
Yeah.
Okay. Other questions on this page?
Can you go down to 6 and 7 again so I can look at them?
Yeah. And again, specific, each problem it'll either say like set builder notation or interval notation, so you have to be able to know, which is which. Questions on this page?
And what was number 3?
Number 3 is choice 2. Oh, by the way, you guys, I don't know if you got that in algebra. You know what the graph of sine x is, by the way? So it looks a little like this. Sine of x. Cosine of x would be kind of like this. right?
So basically the opposite.
Well, it's what we call 90 degrees out of phase, but yeah. I mean, you learn sine, cosine, and tangent in geometry, but I guess you didn't learn these graphs in algebra, so I don't know. But anyway, I mean, it's simple enough, right? It fails the horizontal line test. Okay? All right, let's go to the next page. So number 8, F6 is 8. That's a 1-pointer, pretty simple. Number 9. Now notice here, there's your graph. And 3 points for this, right? Interval notation. Why are these closed brackets and not like this? Right?
Because it's a close.
Because, see, that's a closed circle, right? -5 is included, and 8 is actually included, right? If that was an open circle, right? If that were an open circle instead, then it'd be like that, right? Not including 8 up to it, but not. Does that make sense?
So it's like the middle one is open or closed? No, never mind. Yeah, yes.
Right. So that's interval notation, right? This says it goes from -5 to 8 inclusive, right? And then down here, oh, and by the way, it's the domain, right? So make sure you know when you see domain interval notation, it's from here to here. And then down here, set builder again, and now it's the what?
The range of the
Right.
function.
So then that goes between here and here, right? -3, 2. Right? Inclusive, obviously, right? Remember, this means all y such that y is between -3 and 2 inclusive, right? Then equal means inclusive. You got to have that. If they were open circles, right? You'd have just like less than without the equal. Okay? And then number 4 is this. You guys understand how to get that figured out for number 4? Because there's certain things that can't be done in math in the real number system. We should probably talk about number 10 here. I said number 4. Does anybody not understand how I got x is greater than 4 without the equal to sign?
Yeah.
Okay, why? There's 2 things here. 2 things to look out for. What's one of them? Well, one of them, we're dividing, right? What can we not divide by?
You cannot divide by a negative number.
Yeah, you can.
Oh, no. You can't divide by the square root.
Yes, you can.
Oh,
What can we not divide by?
oh, you can't divide by 0.
Can't divide by 0, right? So that's one of our restrictions with this function. Cannot divide by 0, right? So what would cause this thing in the bottom to become 0?
4.
So x cannot equal 4, right? Because 4 minus 4 is 0, right? And now, what? I thought that was your eraser. Okay. Now we also have a square root. What can we not take the square root of in the real number system?
You cannot.
0.
You can take the square root of it, right? Cannot take square root of negatives, right? So what values of x would cause this in here to be a negative number?
Anything that is lower than -4.
No, anything less than 4.
Less than -4.
No, not negative, just less than 4, because if you're going to
Less than 4,
subtract,
I mean.
right. So let's say x is 2. What's 2 minus 4?
-2.
Square root, right? -2. Can't do that, right? So not only can x not equal 4, right? It also has to be what?
More than.
Greater than 4 to keep that hot, right? So there's two things to look out for, right? So like if you were to do this and maybe you put an equal sign here, is that correct?
No.
No, because it violates that part, right? So we have to have this just x greater than 4 and not equal to. Does that make sense to you guys?
Mhm.
So that would describe the domain of this.
I have a question for 9.
About 9, yeah.
How do you get the interval notation?
Well, it's that lesson we had before, right? If it's these hard square looking brackets, it means it includes this number to the left. So this is -5, right? And it's a closed circle, right?
Oh,
So it
okay.
includes -5, right? Again, if it was an open circle here, if that was an open circle, we'd still have a -5 here, right? But it doesn't include it, so we'd have to have that if it was, right? But then if there's a closed circle out here at 8, then yeah, we'd have the hard bracket on 8. So you can mix up those brackets, whether it's included or not. Okay? Does that help you, Paul?
Yeah.
All right, and so no, get rid of that stuff. How many things do I have to do? I don't know, whatever. So know the difference between interval notation and set builder. And you don't have to do the, you know, y element of the reals or anything like that. You don't have to put that. We're just going to assume that for now as a shortcut. When we get, you know, in the more complicated sections there, then we'll have to specify whether it's a real or not. Okay? Any other?
I'll be
Yes.
right back. My pencil broke and I gotta run downstairs to grab another one.
Okay, make it quick. We're moving on with this.
All right.
The video will be posted. All right, we okay on this page? Does anyone have another question? All right, let's go to the next page. It's the last one, and you should get 18. Do we need to see how to do this one? Average rate of change.
Yeah.
Okay. So remember, like average rate of change is the y2 minus y1 over x2 minus x1. Hey, that looks a lot like slope formula, doesn't it? What slope? Rate of change. But like we're using this, right? So we'll actually do f of, well, let's see here, x2 minus f of x1, right, over those very same x2 minus x1. Does that make sense? So what we have to find is that and
It's
that.
X2 and X1.
Here's our
F of X1.
x2, right? There's our x1. So we plug those in, okay? So let's find f of 3, because that's our, right? So f of 3 equals, let's see, 4 times 3 cubed, right? Minus 5 times 3 squared plus 3. Okay? Well, 3 cubed is what? 27? Right? What's 4 times 27?
27.
It's 27, right? And 4 times 27 is 108, right? Minus 3 squared is 9. 5 times 9 is 45, yeah?
48 plus 3.
40, right. And so when we do 108 minus 45 plus 3, we get 66. Okay, so let's just box it, right? We'll need that in a minute. Now let's do the other one, f of -1, right? And that's why this is 6 points, right? There's quite a bit to do here. It's 4 times -1 cubed minus 5 times -1 squared plus 3. Okay, so now be careful here. What is -1 cubed?
-1.
It is negative, right? If you're multiplying it 3 times, right? Because let's do it. -1 times -1 is +1, yes?
Times another negative.
Times -1 is -1 again, right? So we end up with 4 times that would be negative 4. Okay. Now negative 1 squared is what?
Positive 1.
Positive 1. And then negative 5 times positive 1, that's just negative 5, right? Plus 3. And then we get negative 6, right? Correct? So now we can do this thing, right? I've got these two values now. So after 30, so we'll do 66, and be careful here. Minus parentheses, negative 6, right? Over what minus what?
Over 3 minus parentheses minus 1.
Okay. So up top, it's really 66 plus 6, you get 72, right? And down here, you get 4, and that's 18. Okay? So down here, I mean, I wrote all this stuff up top, but down here is like the work you'll show, and that's why it's, 6 points. There's a lot of opportunity for partial credit here. So I would definitely not just like skip this problem entirely. Like if you get confused and think you can't get all the way through it, right? Because you'll lose a big chunk of points, 6 of them, right? But if you're got your head together enough to at least get some of it in there and get, 1.2, 3, 4, 5 points or something, get them, okay? So any questions on number 11 here? You get the idea? Okay. Let's go back and take a look back to the entire review, because remember that this review, the test is going to be almost just like it, right? So if you can do this review, you can do the test. So to be clear, I don't answer questions on test day, right? Unless it's like a typo or something like that. But I don't allow test corrections, right? These are your test corrections right here on the review, okay? So whatever
I
grade.
have a question.
Hang on.
Is there actually a chapter 1 review?
Yep, hang on just one second. I don't allow test corrections, right? So whatever grade you get the first time, that's it, okay? Your grade on the first try is it. And I don't allow test makeup or retakes, okay? So this is it. Antonio, what were you saying?
Was there actually a chapter 1 review?
Well, we did chapter 1 and 2, so this kind of encompasses both.
Oh, okay.
Unit, we're calling them units now, unit, chapter, whatever. 6.5 dozen together. So now, as you're looking back through this entire review, if anybody has any question, please ask it now, okay? Any of these? Go ahead. Go ahead.
We go over 4.
Yeah. Number 4. Okay. So we got a bunch of ordered pairs. These are all x, y's, right? Okay. And I want to know which value of k here will result in it not being a function. So if it's a function, remember, every input, x, right? Every x has exactly one output, right? Does that make sense? So let's look at our choices here and see which one of those will violate the every input x having exactly one output y. Well, choice 1, if I put a 1 in here, well, I'm looking for another input of 1 that gives me something else. Is there? No. If I try the 2 here, 2 outputs a 4. Is there any other 2 input that outputs something other than 4? Nope. Let's take a look at 3. Let's put a 3 in here. So this 3 outputs a 4. Oh, hey, here's 3, also outputting a 6. That's 2 outputs for that one input of 3. Does that make sense? So that cannot be a function if that's a 3. You understand that or need more explanation?
No, I got it.
Okay. Anything else on this?